Dear audience, you're amazing. Last talk of today in this room, and that's full. Great, good to know. There have been 3 guys who tackled an old VW Polo.
That's correct.
Marc, Loïc, Thibault, and converted that one to an EV. As I'm myself an EV driver, I'm much impressed what you did.
Well, you haven't seen the slides yet, so maybe it's not that impressive. I don't know.
Have fun. Thanks.
All right, thanks. Hello, everyone. So indeed, as mentioned, this is the team. We founded a company a while ago. We were lucky enough to found a startup that also got acquired a few years back. And when we left the company that acquired us, we wanted to try something completely different. We've been working in finance, building open banking aggregators. And so we really wanted to learn something completely new. And we took all of 2024 as a sabbatical to just play with cars, like what can 3 boys actually do but play with cars. Why did we actually decide to tackle on that challenge? Because we saw that the transport industry, automotive, but also when you look at other types of transportation, it could be nautical transportation, whatever, is kind of siloed and also a bit closed. It's not like there's that much open source, big open source projects in the transport industry. And we also were seeing more and more scary stories about cars being hacked or EV charging stations being hacked and all that stuff. And we were like, okay, but what is the actual lifespan of software in cars or any kind of other transportation, and what does it actually mean? Because we feel that, maybe that's just a feeling again, that the security and also the safety of all that software is a bit opaque and very specific to each manufacturer. It's not like what we have in the open source world where everything is kind of transparent and open. And there's no real off-the-market software for cars, right? It's not like you can just buy a used EV and install the Linux of EVs on them. So what does it actually mean to replace the brains of a car? What does it actually mean to create that new brains, software brains of a car? That's a little bit how we got into this hacking project, which is going to look a lot more like a hobby project than a real product. But anyway, come back to this. We also noticed that it's very difficult to make parts from different manufacturers to work together. It's not like you can take a braking system from Mercedes, for instance, and put it in a VW. They don't talk the same language. So how do you tackle that? Because in the end, you have plenty of components that basically do the same primary function. It's just braking, right? So how hard can it be to make them work together in the same way? So why do we have to have completely different languages that these components speak? How can you make them work together? So we started thinking about, okay, we're basically talking about upgrading vehicles. Like it doesn't have to be just converting it or whatever to an EV, but it's also how do you make sure that your car is upgradable or that you have an aftermarket solution for your car or any other vehicle. Pretty much like you have opportunities to install Linux on your old computers or post-market OS on your phone or whatnot. So there's all sorts of open source solutions for these types of hardware, but there's no option for the new smartphones on wheels, basically, because the cars are becoming more and more smartphones on wheels. So what we mean by upgrading is changing the engine to something that's more environmental friendly. It could be engine swap. It doesn't have to be electric, but it can just be something that's polluting less, I would say, or complete EV retrofit like what we did. But also adding some basic things to existing cars, like an infotainment system. Why do you have to rely on some, again, proprietary infotainment system? Why don't you build your own with open source tools? Assisted driving, autonomous driving, also something that would be nice to add on cars. There's open source projects that do this, by the way, especially the autonomous part. You might have heard of Comma.ai, for instance. Or even remote control. So before we dig into the topic, just a real small disclaimer. none of this is road certified. We know it. It's not our goal today. So we did this on our own funds. So it means we used components we could easily find. Also with the second goal that we wanted everybody to be able to get started as well. So this is not running on automotive grade hardware and all that crap because we simply don't have the money for it. But we could definitely adapt it if the need would be there. So now that the disclaimer is done, why don't we try to upgrade this 2007 Polo using only open source software? This is the donor car. It has kind of a history because it was my first car. So this is the first car that I drove, and I sold it to Loïc, who's sitting right there, my associate, a few years after that. And at some point, he wanted to get rid of it, and it got really the good timing for us to work on that project. So we said, why don't we buy it back through the company and actually do something with it? So we worked on it. And this is a pretty heavy slide. I'm not going to read everything. You can read, so you can read by yourself. I just want to show you almost everything we've been doing on that car. Also showcase the mechanical work that, unfortunately, I won't have time to go too much into details in this presentation. And also the hardware and software part. I mean, it's only 40 minutes. I cannot go in the details of everything. So we're going to fly over a few things, explaining how we used open source software with this. And in order to avoid you from falling asleep, I'm going to show you already now what it looks like. And so you can see we just unloaded the car from the trailer. It was about 10 days ago. We moved the car from the place we actually worked on, and we moved it to a storage facility that's closer to the testing track where we're actually going to be driving it. Because, again, not road certified. It's not like you can just drive around with it in the streets. So the car is actually, as you can see, drivable. Now, the reason there's a very big cable is because there's only part of the battery in it, and also it was raining a lot that day, so we didn't want to fry in the car because we removed so much stuff that water leaks in a bit. But anyway, so the car looks like this. It's electric. There's a cable, right? So yeah. And there's actually a huge AC/DC converter that Loïc built as well that is sitting on the passenger seat that converts basically just standard grid electricity to what we need for the car. And so we just plugged it on the wall plug, and then we started driving it. So that's how we tested the car to begin with. So this is what it looks like now. Pretty cool, right? And all that thanks to open source projects. And for some of them, probably unusual technologies, things you would not necessarily expect to see in a car. And that includes Elixir, which is a language running on the Erlang Virtual Machine, aka the Beam. It's also using nerves, which also you probably may have heard of or not. But that is a tool that I'm going to talk a bit more into details afterwards, which allows you to package your firmware for the ECUs that we actually built. There's going to be some Vue.js, some Flutter, and some Phoenix, which is a way for us to build APIs and web interfaces for the components we have. So why Elixir? It's a dynamic functional language running on the Beam. Already mentioned that. The Beam was really made to run highly scalable and highly available systems. Was basically built by Ericsson for telephony purposes. So it's not like it's just going to fall on you anytime soon. So it works quite well. It has a decent footprint for what we want to do. And what is really great also about Elixir itself is that it uses pattern matching as a paradigm, which is really good when you want to parse a series of bytes or bits or whatever, or if you want to parse messages, which is exactly what almost 80% of this project is actually for. So if you see the example on the right, that's the only thing you need to actually parse meaningful information into a series of bytes. And
That really shows you how powerful pattern matching can be in those types of use cases. Another tool we've been using is called Nerves. So this is also based on Elixir, and it allows us to create firmware based on build root. So it leverages all the power of build root, meaning that if you're not happy with the basic systems that they provide, you can still build your own, customize your own. And what it does is that it packages your Elixir code into something you can directly flash on an SD card, and then you can use then on a Raspberry Pi or any other boards. Now, it also supports redundancy of root partition, over-the-air update. So it really has all this flexibility that we can definitely use in a project like ours.
All right. So now that I've settled the idea of what we've been doing, let's look into more details about what we did. First thing is understanding the car's language. Like I said, they speak something together, all the components in a car. And I don't know how knowledgeable you are about automotive and all of that, so I'm just going to explain it to everyone. But there are wires in your car, and some of them are used for components to communicate together through what we call a CAN bus. So it's basically a twisted pair of copper that is running through your car on which all components are connected. And they will emit messages at a specific frequency, and they will also listen to messages that come at a specific frequency and do something with this information, right? So that's, in a very high-level nutshell, what's happening. And it looks like this. So when you hook up a CAN sniffer, so it's basically something you can plug over USB, and then you connect to the wires physically, you get that kind of stuff when you run the car, or when you do something in the car. It can be that you pull the handbrake, and then you see something changing, pull it back, you see something changing. And so you need to start reversing all these messages, because what you see there is you see the ID of the message, you see the frequency at which they're emitted, and then you see all the bytes that they basically contain. And you have to figure out which bytes are basically linked to what behavior. If you light the beams, something will happen. If you open a door, something will happen. And you have to figure this out. And funny enough, when you start doing that kind of work, and that kind of cumbersome but fun work, you start also realizing that there's very little conventions in the end. An open door on a on a VW car will be represented by a byte of, I don't know, FF, for instance. But it's going to be 43 for another component. So on and off will have completely different values based on the component you look at. So standardization is not really what we can see, at least from cars of that era. This is not that great. And the impression we have is that it's still not that great today, but we don't really know. We will see when we try. So yeah, doing this, you basically start figuring out what the car is saying, or what a specific component is saying. And then you have to put these information into some kind of files. The standard in the industry is DBC files, which you can find some repositories of, because people have been doing this kind of stuff for some time now. I'm just mentioning the OpenDBC repository from Comma.ai because it's an interesting repository, and it gives you an idea of what DBC files look like. Kind of an ugly format, to be honest, but that's the industry standard. And we decided to make our lives easier. And we built our own library to deal with all of that in Elixir, in the language that we use for our firmware. And what we basically did was go for YAML instead of a cryptic format that DBC is. And what it allows us to do is to specify which frames are being received, which frames are being emitted, at which frequency, which IDs, and all of that. And then we can write Elixir code to deal with these messages.
And so that's a complete library that we built specifically for this project and that you can find on GitHub as of today. Let's look at what the whole system looks like now. And on top of it, you see all the components that are from the Nissan Leaf. So we have the actual motor, the inverter, the charger. On the left, you have kind of standalone components that we are using connected to a completely different CAN network. So you have the battery management system, steering pump, and the brake booster. And on the far right in green, you have all the existing components from the Polo. So this is the ABS, the dashboard itself, so the cluster, the ignition lock, the doors. So all of that is actually being connected through specific CAN networks that we created within the car.
And then in the middle, it's everything we built ourselves. And as you can see, so we were in the business of building banking aggregators. Now we basically built a canvas aggregator because you have the vehicle management system on top, which connects all of the different networks together and deals with the translation between all of these components and canvases. And that's really what allows us to have this new brains for the car and allows us also to use components from different brands inside the same vehicle. The vehicle management system is a central piece of the platform that we built. Then we have controllers that are running the same code. They didn't used to, but now they are. Then the infotainment and all of that. The first step we had to do was to get the leaf motor to spin. So when you open it up, that looks like that. So it's not really your usual PC, whatever. It's a bit more difficult to understand. But we needed to find the correct canvas messages we needed to send in order to make it spin. So you get the motor, it's pretty heavy, you get it from the delivery man or woman, I don't remember who delivered it. It's quite heavy, but you don't know if it works until you make it spin, basically. So fortunately for us, there were a lot of reverse engineering of these motors available online. And we managed to find the right CAN messages to send in order for it to spin. And then the next step was to use the gas pedal of the car. So we could have bought a completely new gas pedal, whatever, but we thought, hey, we already have a gas pedal. And it's basically just a potentiometer. So we can just put an Arduino, connect it to an Arduino, read the values, and that will basically be the throttle that we expect. We expect 100% throttle when, pedal to the metal and 0% throttle when it's completely released. And so that's basically what we did in first instance, the first iteration of it. We wired it on a plank and we put the wires on an Arduino. We started looking at the values and then we created the CAN messages that were going to be sent to the vehicle management system. And that's how we got started. You can also see that we have I'm not going to try to use the pointer on this, but we also have something extra at that stage of the project, which is the gear selector, also on that controller, PR&D, because at some point we need to decide in which direction the motor is going to spin, so we initially added it to that controller. We also had to build specific controllers for the relays, now the contactors, because for such a motor to actually spin and receive current, you need to activate relays in a certain order. So you need to activate some phases in certain orders in order for it to actually spin. And in order to control that order and to make sure we were not going to fry, we built those controllers to do this for us. And in the beginning, we used the standard relay hat from Arduino, but somehow they were conflicting. And then at some point, we had the first epiphany, which was the engine spinning when we were pressing the gas pedal.
And we call it the plank prototype because everything was literally screwed on a wooden plank. And that was the very first time that we got to celebrate because we had something that was actually working. I should probably mention that none of this would be also possible for us without 3D printing. So there's been a lot of 3D printing involved in this project. You'll see it when we move to the more professional prototype. There's been countless hours also spent on making plans and printing and all of that. So kudos to these great printers that we've been using for this project.
So we had to go with something a bit more professional and iterate on the plank prototype. And that's the version we have right now. All 3D printed cases, completely new plugs that we had to wire ourselves. You basically have the VMS on the left, which is a Raspberry Pi 4, several canvas hats. You have also the generic controller in the middle, and some hub that we built because we needed at some point to have multiple ways to connect devices. And we wanted it to be possible for us to connect new devices really easily to the whole platform. So we built those small CAN hubs. So the VMS is structured like this. We have build root running. On top of that, we have Nerves running the Erlang VM. Then we have our backend core and API in Elixir and Phoenix. And on top of that, we also have a dynamic web frontend in Vue.js. Why am I mentioning that this is dynamic? Because the way we created our open vehicle control system is through what we call composers. And you can basically compose a vehicle from any available component you have in your repository. So in this case, for instance, we can see that on the left, this is the composition of the vehicle we have today. And you can see you have the Polo dashboard has a contact source because they need to know when we flip the key. The contact source is actually going to be the ignition lock of the Polo. And then the rotation per minute source, which is a parameter of that specific component, is provided by something that has nothing to do with the Polo. It's a leaf inverter that we get the messages from. So you can really mix and match all types of components in the same vehicle by doing this. And you just, of course, there's still some more to do, but you just have to work the code to write the code that fits to that specific component somewhere in the repository, and we will go and fetch it. For instance, in the inverter also needs something specific. It needs the ignition lock. The front controller is an OVCS component, so this is from the OVCS1 car. So it allows you really to compose a vehicle any way you want. And we wanted to push it further because we also wanted the dashboard itself, what we show, the interface that we show, to also be composable. So you can have blocks on the page, you can show graphs, you can show tables of data, and you can go get it from any component that is running on your car. And that basically looks like this. So, hang on, let me go back one. Okay, so this dashboard composer interface that I showed you actually allows you to see all of that data without writing a single line of code. And you can just hook up to that Raspberry Pi with your laptop or whatever. The car is actually connected on the internet where we worked, and then we could just diagnose the car like this. It was kind of easy to do.
Generic controller. So in the beginning, as I mentioned, we had specific code running on each of the controllers. So those controllers are used to gather data from the gas pedal, for instance, or activate relays. But each time we wanted to change something on those controllers, we had to find a way to update the firmware on them. So we decided to opt for a different strategy where it's actually the VMS that's going to adopt controllers and give them the configuration that they are expected to have. And so all of that happens in a specific adoption process that we created, which allows us to have exactly the same code on every controller, to adopt them once, and then they have the exact purpose that we want them to have. Now, since this is a pretty old car, it's not like you have a pretty cool infotainment system on it, so we thought it would be nice to actually build our own from scratch using Nerves as well. And also we needed a way to select the actual gear, so PR and D in our case, because we didn't really want to have extra buttons in the car to do that. And yeah, that was really the idea for the infotainment system at first. And for this one, we actually went for Flutter to build the interface. And this is also where we will show later on information about different system statuses in the car.
In the beginning, we had a complete Vue.js front-end running in a browser. So it was basically starting in kiosk mode with Cog and WebKit, and it was showing a web page. And we had poor performance on real-time graphs, so we decided to try something else. And so we went for a specific fork of FlutterPy that works on Buildroot, which happened to work pretty well. and we haven't looked back since. Now, Flutter might not be the perfect technology for this, but at least for what we've been doing on this use case, it's pretty neat. What does it look like in the car? It looks like this, a bit messy, but on the bottom left you have the VMS, you have relay boxes, you have the back controller in the middle, and you can already see a bit the RC car that we've put there in the trunk. Because when we were testing the RC driving, the only component we had available was on the car, so we hooked up directly on the small car. So the small car was controlling the bigger car, which was kind of fun, but anyway. I'll show you a video of this afterwards. All right, small adaptations we had to do to the car. Really quickly on this one. I don't know how much you want to know about mechanical stuff, but in a car of that age, the braking assistance is actually provided by the thermal engine, in the sense that there's a depression that's being caused, and that depression provides you braking assistance. But guess what? We don't have a thermal engine anymore, so you have to find another way to provide braking assistance. And so it happens that Tesla has a pretty cool component, which they call the iBooster. Just provide it 12 volts, and it provides you braking assistance. So just swap it, and that's it. Hydraulic pump. Remember that small box on the left in the small architecture diagram I showed you? This is the hydraulic pump for the steering wheel of the Polo. And it so happens that this kind of device only starts when the engine is running, meaning when the diesel engine is at idle RPM level. But right now we have a motor, an electric motor, that has 0 RPM when it's powered on. So we need to find a way to force it to actually start. And so we have to control it completely independently from what it used to be. And so we had to reverse engineer the CAN messages and send the CAN messages at the right moment. Anyway, another thing is building the batteries. Yes, we didn't buy existing batteries. We took used cells and wired it all together. Pretty dangerous work. Don't necessarily do this at work, but it took us a lot of time to make this right. A lot of 3D printed pieces, like I said. There's plenty of stuff there. So, we have an electric car. Why don't we transform it into an RC? We already know we can accelerate, right? We can send CAN messages to make the motor spin. That we know. How do we brake? How do we steer? That's still a question for us. Braking actually turned out to be easier than we thought, because the Tesla iBooster is basically what you have when you have autopilot. So it also has CAN messages that can control the rate of the fluid that goes through the pump. And so you can actually control that with CAN messages. And we managed to reverse that as well and figure out what to send in order to do that.
And at some point, the braking pedal started moving based on CAN messages. So that was a second win for us, and we were quite happy to see it move. So braking, that's done. The next step was to figure out how to steer. And at first, we tried to reverse engineer an existing steering column from a more recent Polo, but we kind of failed doing that. So we decided to just strip away its ICU and servo motor and just put one of ours on it. So it means that the steering column is now controlled by an Arduino with a controller, like a generic controller, like I explained before. And this allowed us full flexibility over how to actually control it. So we don't depend on the manufacturer's ECU anymore for this component. So it's kind of different from the approach we took for the brake booster or from the motor. But at some point we needed to find a way to move forward with the project, and clearly at that point reverse engineering the steering column was not working in our advantage.
But the car that you saw driving before in the beginning of the talk has this. So if you have the remote control, you flip a switch and then you can control it. Unfortunately, we didn't have a DeLorean at hand. For those that remember Back to the Future, it would have been way cooler to do this with a DeLorean, but yeah, because it's pretty much the same experience that Doc is actually having when he drives it in the Two Pine Mall. What now? Okay, so we're at this stage. The car is there, it's stored. We're going to test it somewhere in the next few months at the facility. We need to reserve the place and all that because we can't drive it in an open road, so we will drive it in a parking lot that's dedicated to testing vehicles. And also there's a track next to it that we can use as well at some point. What are we doing now? What are we still working on? The OVCS Mini. It turns out that doing remote control stuff and autonomous driving on a one-ton car is not necessarily super safe, so you probably have to test things on a smaller vehicle that will not kill you. And so everything you saw, all of the stack, the hardware and software stack, has been put into an RC car that's much, much smaller. But it's actually exactly the same stack. And it's just that the composer for the vehicle is slightly different because there are some components that don't exist. There's no inverter and all that, but the platform allows you that flexibility. It also uses CAN bus to work. We are also working on a ROS2 bridge for the car so that you can teleop it or you can hook it up to any stack that exists for ROS2. The cool thing about this bridge is that it's not going to run Ubuntu. There's an actual Elixir client for ROS2, which runs on Buildroot. So it's much simpler. We have something that's super efficient. And also working on a perception stack at the moment. We have a few things running right now. But again, all of these things at some point need to be put together and make sense. So right now we detect objects, we send the objects, the bounding boxes in the classes to a ROS2 topic somewhere. So all of this is in progress and will at some point be put together into the same bridge. There's already rudimentary lane detection as well. That is not shown here. Another component, because why not, is an OVCS remote. Because instead of using an RF transmitter, a Mavlink remote, we thought it would be nice to have a multi-protocol, something we can put data back onto a screen. And it's also just cool to figure out how these things work as well. So again, all of this built with open source software. I didn't show much code, sorry about that for those who wanted to see it. But all the code is open source. For those asking, yeah, but what about the hardware? The hardware will be as well, but you know that documenting hardware takes more time than documenting software, even if our software is not well documented at the moment. But we will definitely release all of this very soon in the next few months so that everybody can see what we did, how we did it, and have an idea of how fun it is and what fun they can have. And again, small reminder, none of this is road certified.
It might be one day, but you need to look at this as a massive hobby project that we've been working on. So if you want to find out more about this project and follow the progress, you can look it up on GitHub right now, or just drop us an email. So thanks for attending this talk, even though this part is being recorded afterwards. And thanks for your attention.
And so on the RC car, somehow the pigs started going crazy, and it was basically spinning the motor at 100% throttle. So the RC car just went completely to the wall. If that would have happened on the big car, we would have been in trouble. So that's exactly why we want that small scale car. Yeah, there's a question over there. I think he really wants to ask it. Oh yeah, there's questions everywhere. Sorry. Okay, 2 microphones. Only one speaker.
I struggle to find time to play with an ESP32. Can you tell something about the human resource part? How much time of your life you put into this thing and how much budget you actually put into this project?
So we didn't work full time last year. Again, we were supposed to also take a rest and all of that. But we did work about 3 to 4 days a week for the whole year, 3 people. So I wouldn't say it were long days, by the way. It was not like a 9 to 19 or something like that, but much shorter and sometime with a beer. So yeah, I would say maybe 1.5 full time over a year would be a pretty, 1.5 full time over a year would be a pretty fair statement. In terms of money invested, there's about 25K that we put in the car. Nobody would be crazy enough to put that kind of money on an 07 car, but that's pretty much where we are right now. Everything's self-funded, and that's why we also are going to take some contracting work this year, because at some point we need to eat and pay rent. But yeah, all right.
I have a question regarding something like this that was showed there. Let's say that there is an audit performed. So how do you make sure that this kind of an audit doesn't trigger something that would be reverse engineering for even something different, right? I mean, I think it opens a dialogue here, because some stuff, like those parts and everything, needs to be connected out and checked for whatever reason.
Yeah.
And how to make sure that the process that's involved in there, I mean, we
doesn't
can talk
disturb
about
existing.
that won't bring or trigger some kind of a weird another issue, or maybe reverse engineering even, and fucking sell out to Dino China.
Yeah, you don't. It can happen. Fortunately, it's not like we have, the only ECU we have stripped from a component is on the steering column we used.
System was bound to both the vehicle management system and the Nissan Leaf can. Is that a problem with the diagram?
No, it's on its own CAN. It's on its own CAN network. Yeah, sorry, the arrow is a bit weird, but it is completely separate. It's not linked to any other. And the reason we have all these CAN networks is because manufacturers may have chosen the same ID for messages, but to do different things. So you don't want them to clash together on the same network. So you have to keep them separate. Oh, yeah.
I was wondering.
Yeah, go ahead.
Yeah, okay, cool. I was wondering, you mentioned like safety is the first priority, and you're going to do testing. What fail-safe do you have in place, like for when you do this test, that if something goes wrong, you have a means of stopping the car, or
So you don't see it that much on the last picture, but anyway, it crashed. Anyway, there's a big red switch inside the car. If you trigger it, so if you just trigger it, it shuts down all of our platform. And you're left with two things, two mechanical things that are still existing. You're left with the steering wheel, that still works, and the brakes, that still works. You don't have any throttle anymore, and you don't have any component of ours that still runs. It just shuts down everything. And cuts, of course, the high voltage. So it really cuts everything that can go wrong, and you just have to find a way to steer the car and brake. That's as safe as we can be while testing, and also you don't notice it, but there's a small thing you can pull at the side of the car. Sorry? Meaning that when we will test it for autonomous driving at very low speed, we will be next to it, and if anything goes wrong, we just pull it off. But it's likely we're going to have somebody in the car in the first steps for these ones as well.
I know that when that's a pie because it's cheap and you can easily put it everywhere. But what if it's really hot or cold, and pie will not act and run in the same way when when you go up and down. And for the car, you need something that can stand like a plus 40 or in minus something. So did you think about to use some other board that's also free there and that can stand that, or?
We looked into other alternatives, but it felt like the easiest to find was Raspberry Pis and Arduinos, so we went for this, the cheapest as well for what we were doing. But yeah, there are other boards that are probably better. We just haven't done a complete analysis of it. So yeah, it might break if it's too hot or too cold. We won't drive it at minus 40.
Hello. Thanks for the presentation. I got a question about...
Again, it's something that's literally a lab on wheels, more than something that's meant to be drivable. But a different platform, different car would have made it different, of course. But with the car that we had, which is a city-size car, this is how we built it. We could also have put the battery somewhere else or whatever. But anyway, there's always something you could have done differently. But yeah, a lot of this, Loïc also did all the welding job. We had to weld, for the batteries to be slid into something that is closed, I would say. We have aluminum boxes that were welded so that we can put the battery pack.
If there are other people who develop cars that are similar.
Well, yeah. First we need to test it, see how fast it drives, and then, well, first we need to make sure it's safe, and then see how fast it drives. So yeah, that's definitely one way this could go. We will see. Honestly, it depends on what the testing says. Okay. Yeah.
Hey.
Yep.
Working with Elixir, you often hear "let it crash" for handling. Does it work with your?
No, we don't want the car to crash. So it does indeed give a different meaning to the saying. No, of course. It's.
Hey, so one more. Hardware aside.
Oh, yes, sorry.
Hardware aside, have you, you said that maybe someday road legal. Have you given it any research? How much would it take to actually make just the software, road legal?
No, we haven't.
Hey, thanks for your presentation. And I have a bit of a meta question, which is, you mentioned that, we could have tried this, we could have tried that. And that really interests me because this is a very open-ended project.
Yep.
And since you're doing it kind of on your own schedules, you could have gone in any direction.
Yep.
So but yet you still got a lot done in a very short amount of time. So how did you kind of keep your eyes on the ball and not get focused on let's do something else completely different and abandon this project?
I think we were always focused on the goal of making the wheel spin. So there's a few milestones that we wanted to reach. First was make the wheel spin. And so the first step to make the wheel spin was make the motor spin with the pedal. So something like that. So we got lost also in many directions all the time. But we always came back to, okay, what's the next goal? So when we felt we were going astray, each in our own direction, we would sit back and say, okay, but what's the next goal? And say, okay, we want to show this at this conference. We want to show that at this conference. So also, again, conferences like this or talks are a good way to, kick you in the right direction because you want to show something at that specific moment. Sometimes you make it, sometimes you don't, but at least it gives you a goal. So you can go astray, but then if you come back to something tangible and you have a reason to, then it's easier indeed.
Hi, thanks for the presentation. I was wondering how long it takes until the system reacts to input as you're booting Linux and then a virtual machine. So,
well, we haven't noticed any significant latency, honestly. But we haven't driven it at 120 kilometers on the highway. So we don't know yet. But what we can see is that the frames are being emitted or received at a pretty decent frequency. So it's not like the footprint is making it completely insane. So it's not like messages we're expecting every 100 milliseconds are suddenly coming every 200 or 300. So the boot time. Okay. Boot time that we have with this. So the infotainment you saw were about 6 or 7 seconds to boot the screen. The VMS is running on it's running on the Raspberry Pi 5, the infotainment system, so it's a bit faster. And then the VMS is pretty much the same, I would say 10 seconds to boot everything up. But the idea is that it would be always on. Just like on an EV, most of the systems, they stay always on. And when you get into the car, then it lights up. But there's a lot of things that stay up in the car. And that would be the idea. Since we have this huge, massive battery, we can just, take a bit of juice out of it to keep our platform always on. And what turns it off is actually the big red switch itself. And if you keep it always on, then you don't need to care about boot time. It's only when you switch it on again that you have that problem. But we want to stay below the 10-second boot time for everything. That's what we aim for. And for now, we've managed to do it.
Hi.
Okay.
What did you do with the entire instrument cluster stack? Since I noticed it didn't seem to be there anywhere.
Yes, it's still there. And you can watch Thibault's talk from yesterday because we also wanted to make it as seamless as possible, the changes that we made to the car, so that it's actually the RPM needle shows the RPMs of the Leaf engine. So we basically went there. And the next step when we have everything right with the battery is also to use the fuel gauge to show the percentage of battery left on the existing fuel tank gauge. We've already figured out how to use a digital potentiometer to do that.
Out of curiosity, does the RPM range fit? I guess it's a little out about the electric engine RPM.
But in most retrofit work, you will see people changing it, basically, which we find a bit stupid because it's already there. And it's kind of interesting if you go to that level of integration. So it's really you don't have a separate button to start the electric motor. It's really the Polo ignition lock. So you do it like you would do on a diesel engine, and it starts the motor, which is pretty sweet because then it means you don't have an external system to start everything. If you have the CAN messages for all of that, you can trigger whatever you want on your own platform like this. And it makes the integration as seamless as possible. And it's almost like the car was electric to begin with, which is really nice when you're inside the car.
Is it? Yeah. Thank you. Very inspiring talk. Is there any practicality of your project? What is the goal? Because it's open-ended. You said it's never going to be road safe. Software is pretty customized.
Never say never. For now, it's not. But what's the goal? That's quite interesting question. I wouldn't say we have a definitive answer to this one yet. We don't know yet. We know what milestones we want to reach. What we want eventually is to see it drive alone around the track. That's what we want. And we will put the work into making it happen. What's interesting, however, is everything we've learned along the way and gives us ideas of things we could be doing either with the platform or completely different things we could be doing and products we could be building. So the goal there was really learning new stuff, figuring out what we want to do in the next years. We haven't answered all those questions yet, but we have accumulated quite a lot of knowledge and interest in different topics that we didn't have before. So it was really the opportunity. It's something you never have an opportunity to work for on a production environment, right? Even research projects at universities don't necessarily go that far in that direction, reusing existing parts and all of that. So it's completely, a bit crazy, I would say, but yeah.
Hey, amazing talk, thanks. I wondered why you used cells for the battery. Did you buy them with the motor? Was the motor used as well, or did you buy like a new motor and for some reason have used battery cells?
So one of the things we did and that we would have done differently is that we kind of went to an EV shop online and we said we want to buy a kit to convert a car. And it turned out that we didn't really receive a working kit. So the BMS, so the battery management system, was not the right dimension. They gave us also an ECU that was not compatible with, so it was a mess. And fortunately, we got some money back there. And for the battery, we were supposed to get an existing Nissan Leaf battery. And it was not coming, and at some point we said, okay, you need to find an alternative. And they sent us battery cells from a Nissan NV200, so that's what you see there. It's pretty much the same battery cells, but configured differently. And so what we noticed is that we just got the cells. There's no bus bar, no wires, nothing. So you have to You just see this when you start working on it, right? You say, oh, where are the bus bars? And so you have to figure out all of this by yourself. It would have been much easier to have a battery pack already done, 2 cable, let's go. But we didn't get that. So I wouldn't say we were scammed because we got something for a fair price. But that was definitely not a ready-made kit that you can just put in a car. And I think that's also something when you start converting cars, or if you want to do converting cars, EV cars as a hobby, be very careful with what you can find online and all that. You will receive stuff, but maybe not everything will work together as it's meant to. And so we had to figure this out. We still have to figure out quite a few things also with the BMS and all that. So yeah, it happens.
Hello. Very relevant talk. Thank you. I was also reverse engineering CAN bus and LAN bus on Volvo V50, and I wonder, like, you did much more. So, like, I published IDs on GitHub. So, do you know maybe if the same model of the same year, like, do they reuse the IDs? Does it make sense to publish the IDs you scanned?
VW has had different platforms. Platform meaning electrical and communication platform. The one from that Polo, I think, is PQ24. I don't think it's... anyway, so I think they had 24, 25, 26. So, and the PQ platforms were just evolutions on the same one. And then they went for MQB or something like that, which changed completely because they went for a platform that was... if I remember correctly, maybe I'm saying stupid things, but which was supposed to be the same for all of their brands, like Skoda and VW and all that. That was the MQB platform. So there is already some documentation available for these platforms, but not everything is there, by the way. But what you will find is people that recorded a CAN bus trace along the way. So they just drove the car, got a CAN bus trace, all the messages for, I don't know, 5 minutes, 10 minutes, and then they dumped it online. So a lot of that you can find. By the way, if you plan on reversing CAN on a car you're working on, don't remove the diesel engine first, because when we started the project, we were like, yeah, let's just remove the engine. And then, okay, now we need to reverse engineer the CAN, but we don't have probably what is a central piece of the car. So yeah, anyway, so you can find some documentation online, but it's not perfectly structured in a way that you can easily find it. Sometimes you find information in forum threads, sometimes you find information on GitHub, sometimes you find information by just talking to people on a random channel somewhere. So it's a bit of a rabbit hole.
Like, I mean, if you reverse engineer, for example, one component of this car, maybe you know, like, from your community feedback, that the same component in the other car, does it use the same IDs, or it might be completely different? Do you need to reverse engineer, like, in every car, the same component?
We don't know all components of all brands. It might be that sometimes they use a standard configuration for the component. We don't know. What we have seen, however, is that the iBooster from Tesla, so the servo brake system, it's also used in other cars. So it's a Bosch component, basically. It's a Bosch component that is used in several cars. But it seems like the IDs of the messages are different. So they probably programmed them somewhere at the manufacturer, or even maybe they programmed them at Bosch. We don't know. Maybe they send what needs to be on there without the IDs and all that to Bosch, and then Bosch configures it. So not always. But in some cases, it might be the same messages. We don't know. There's so many components there that we don't know. Last question, probably.
So are there any elements that you're looking for contributors for? Or are you looking for contributors to the project at all? And if yes, what elements or what could people do to help?
Okay, I was not expecting that question. Well, if you want to get started, send an email. We would happily help you get started and figure out what's missing or how to... Right now, what we've done is mostly limited to the components we had access to. If someone could just build, components from other cars just by connecting to the CAN bus and creating other things, that would be quite amazing. To add new components to the platform, because it would make it much more open. There's also ongoing work. We said the ROS2 bridge and all that. There's still stuff to figure out. So there's plenty of things to do, but it's not like we have a list of things that contributors could jump into. We would love to keep working on that project as well, even do paid work based on that project. But for now, it's just, again, we're just showcasing it to see if anybody would be interested in working with us, or a company that may be willing to pay us to keep some of that work going and use it in their own products or use it on their own use cases. But so far, it's not the case. So we're taking on some other contracting work this year. But yeah, anything that can help us keep, keeping this alive and keep working on it would be great. And if you want to help, just send us an email and we will happily see what can be done. I'm over time, so thanks everyone. I'm still around, so if you have more questions.
Many, many thanks.